Experimental design. In this lecture, I will define the basic concept of experimental design, and then we will talk about what are criterions for well-designed experiments, and then we will talk about experimental validity or research validity, and then we will getting in more details threats of the research validity, internal validity, and external validity, especially in experimental setting. And then we'll be getting into what type of experimental design, pre-test, post-test, post-test only, types of experimental design. We will talk about it. And then, ex- interpreting results a little bit, how to interpret those results, right? And then we will summarize. I don't think we will talk about randomness and representativeness too much in this class. Right? Right. What is experiment? And what is experimental design? Our textbook 134 says an experiment is a research study in which at least one independent variable, which is experimental variable, is manipulated and varied by the research. If you have independent variable, at least one independent variable is deliberately manipulated and varied by research, that is experimental research. If you don't have any independent variable, which is not deliberately manipulated or varied, that cannot be an experiment, right? So, for example, you had a treatment. You define the treatment as independent variable, and you design level of treatment, control group, experimental group, control group, experimental group 2, 3, 4. Who decided that treatment variable? You decide. That independent variable, you designed it, and then you manipulate, deliberately manipulate for your study. A lot of independent, like for example, gender cannot be. Why? Gender, you observed it, but you didn't create two different type of gender, especially human subject research. You didn't assign subject gender into, hey, you become a female, you become a male, right? So we call it as observational variable, non-experimental variable. So be careful your independent variable is experimental variable or not. And your own study, create your own study, try to um, you know um, try to include that experimental variable to apply this research design learning to your own study setting. All right. Definition of experimental design is the structure by which variables are positioned and arranged in the experiment. And if you experimental design is now structure, you setting up the structure, how to implement that experiment. Okay, experiment and experimental variable and experimental design to perform that experiment using experimental variable. Are you with me? So all three things are not exactly same. Experiment, experimental variable, experimental design, right? But they're related to each other. That's common sense. And look at this one. And the G stands for three different groups, and X stands for treatment, independent variable. So independent, some treatment, treatment Y, treatment M, and treatment B, right? So you assign, and then you design three groups, and each group receive their own treatment, treatment A, B, C, for example, and then are representing. You have randomly assigned subject into each groups. So now are again are represented random assignment onto the three groups, and each group receive their own treatment Y, M, B, right? So this group membership, treatment group membership, becomes your independent variable, or you can just call it as treatment as independent variable. What do you mean by O? O stands for outcome or observation, observation or outcome. And then you measure outcomes for each group separately. O1 stands for observation or outcome from first group. O2 stands for observation or outcome from second group, O3 third group, etc. Right? So this is another example. You can create stress college student stress reduction techniques, and then you can create three different treatment. One is yoga, the other one is mindfulness meditation, and third one is breathing exercise alone. And you create the three different scenario, and you randomly assign subject into three different techniques as a one group, second group, and third group. And 40 minutes looks like 40 students are randomly assigned to first group, second group, third group. And then you develop some assessment to capture that stress level. You call it as O. It includes instrumentations and etc. etc. Right? Again, if you design this way because you researcher create this situation, and then still we call it as a treatment is independent variable. Treatment effect onto dependent variable, which is what? Stress level. Right? So entire those, and then also important vocabulary taxonomy is levels of independent. How many levels they have it for this treatment independent group? Three levels. Each group representing one level, like a categorical variable. Yoga is one level, mindfulness meditation is another level, and exercise is third level of treatment. Three levels. Make sense? Okay, let's move on. I mean, it will, in your brain, you have to think about your own research. What could be the treatment for what could be the dependent variable, and what could be those level, how many levels, and you can imagine at the same time right now. Hmm. Yeah, in here, same. The first group, first level, second group, second level. How many group, how many level? In here, what is independent variable? I mean, treatment or techniques are independent variable, right? What is dependent variable? Stress level observation, some kind of stress level observation. Okay, again, levels refers to the groups or treatment levels. And typically we do 2 to the 5 groups in social behavior science. And subjects and participants are slightly different. Subjects are very related to participants are everybody involved in your study. Sometimes the teachers are participants of your study, right? And other peoples are all participants of study. Subjects are related to your dependent variable. Key variable came from where? Yeah, from students. Students are, those dyads are subjects. Right? Again, if you're working with the counseling lab and they're doing a research, experimental research in your counseling lab, right? Counselor could be participants of your study, right? But not necessarily subject for your study. Sometimes your students are subject of your study. Sometimes your teachers are subject of study, right? So the the key idea is the dependent variable came from whom, right? So that is a key idea to differentiate subject and participants. Criteria of for well-designed experiments. Number one, adequate experimental control, right? So your experimental control random assignment should be adequate, sample size, and other issues. Number of levels should be reasonable, right? And practical applicability. We will talk about adequacy of experimental control later, but practical applicability is also very big. It should be doable, ethical, doable, and reasonable cost, right? It's too expensive to doing it, unrealistic doing it, and those all those things are related to well designed experimental research, right? Design, right? And also basis for comparison is very, very also important. Hey, what do you mean by improved? You're getting better than what? Right? From where? So that is the reason why typically we include control group into our experiment. So they don't receive any treatment, new treatment, or old treatment, previous treatment, not a new treatment, right? So idea of statistical analysis, one of the fundamental structure to answer your research question and test your hypothesis is creating contrast. Oh, compared to this group and the other group, right? So having a sound basis is very important. If you if you do treatment, if you argue your treatment improved, but improved from where, right? Sometimes improved from preconditions, pretest conditions after your intervention, and then you measure again. And then post intervention, post test scores greater than pretest score, that could be your argument. Or sometimes you design to basis as a control group, as I explained to you, not receive any treatment group, right? Adequate, uncontaminated data, right? Sample size need to be reasonably large, and you should not have too much measurement errors. A lot of social behavior science, we are using our own instrument, even though they validate it. You have to double check reliability, right? And relevance of the dose validity information is still applicable and generalizable to your own study. Otherwise, your instrument sucks. So your data sucks, and then your analysis will be what? Conclusion will start misleading. Fifth one is freedom from confounding and relevant variable. And of course, this is fundamental reason why we are doing experimental research, right? Even though you create the experimental research, there might be some uncontrolled variable effect coming in. We will talk about those issues later. Representativeness, and you need to design your study as generalizable as possible. Sometimes you create the research design which is so peculiar. There's no way in real life in another situation we can find it. That only works in that research lab, right? Hard to generalize that one to other occasion, other situations. So you have a lack of external validity, which is generalizability, right? So design your experimental research as generalized as possible. Seven, parsimonious and simpler the better. Don't make your research design is overly complicated, right? And then you will have what the complication make your understanding weaker, and also understanding what's going on unclearly. So simplicity is very, very important. Okay, experimental validity, we will talk, and and internal validity, external validity, and we already talked about those two different type of validity also apply to experimental research as well, and we call this experimental validity. And construct validity, we call it a measurement validity, and we will talk about those measurement validity issue later. But all related to each other. I know it's very important construct validity and experimental validity, but we will talk about we need to spend lots of times to talk about what do you mean by construct validity. In this class, we're not talking about external validity much. External validity is what? Generalizability, how your result can be more generalizable, and we will spend more time in this external validity with sampling design. Inside of research design, there's experimental design, sampling design, right? We will talk about external validity and sampling design. And in this class, we will talk about more internal validity issue, right? To what degree are changes in DB due to IB? Okay, dependent variable changing it. How much of the, how much independent variable explain that variability of dependent variable? That is a key question for internal validity and specifically tenability of that causal conclusion. Are we really sure to say my independent variable cause dependent variable? How strongly, right? The degree of that tenability of causal conclusion, internal validity. We already learned that one. All right. And the other type of very important validity we will talk about later is a statistical conclusion validity. So whether you take it statistical training, basic training or not, and statistical conclusion validity is you statistically you say, oh, this I reject a null hypothesis, retain null hypothesis, right? And I think this average is greater than the other averages, right? So you make a lot of decision with statistically, but there's a lots of assumptions requires to draw that conclusion, and most of statistical conclusion is related to assumptions of those statistical method, right? And then also appropriateness of choosing, method. Sometimes you choose wrong analysis option. So whatever your conclusions you draw is not so much valid. But that's not a experimental research issue. That's not a sampling design issue. That's more like a statistical method issue, right? So statistical conclusion validity is related to um, those issues. Again, sometimes in general, your statistical conclusion will be not validity will not be high if you have a too small sample size. And nowadays, it's very you know um, challenging thing is if you have too much sample size, your statistical conclusion also not meaningful. If you have too much sample size, statistical conclusion can also not meaningful. And also data fishing. A lot of people are clever enough. They know how to play around the data. So they can draw conclusion whatever they want by manipulating those data and models and they draw some conclusions. So unless other people, so our readers are clearly understand what's going on stat, right? So we have to believe what they did. That's the whole point of what we are learning this type of thing. Instead of they read the chapter 5 conclusion, we want to evaluate their work, critically consume their work, because a lot of data fishing going on in empirical research world. All right. So this is it, and the next part is threats to experimental validity. Okay, threat to experimental validity and variables and experiment internal validity, external validity. Purpose of research design is control for extraneous variable. Confounding variable is an extraneous variable does indeed influence on the dependent variable. So extraneous variables, every other variable, potential every independent variable. Confounding variable is indeed influence on my dependent variable, but which is not our main independent variable. So other still other variable, but indeed influence onto, you know, influence to my dependent variable. The goal of research design, experimental design, is try to control those confounding variable through experimental design. One of the key point of experimental design is we able to use random assignment, randomized control within experimental variable. We will talk about random assignment in detail later. And then experimental variable had a experimental research as more than random assignment, but I would say random assignment is key weapon. How to control those confounding variable, eliminate confounding variable effects. Right? So our textbook described that one in a long, lengthy, way to understand this purpose of experimental research. Right? Again, extraneous variables are independent variable, and which is different from my independent variable, potential independent variable, and confounding variables are subset of extraneous variable, indeed influence on my dependent variable. Purpose of experimental research is try to control for those confounding, eliminate effects from confounding variable. What is another name of the confounding variable? Spurious variable. I mean, extraneous variables also sometimes they call it as spurious variable. Okay, necessary condition for causality, and sometimes look at this independent. There are independent variable and dependent variable. If you want to say A cause B, right, and you should meet three different conditions. If you like to say A cause B, I know this is new lecture notes. If you like to say A cause B, three conditions are needed, right? First of all, variable A, variable B must be directly related to each other, theoretically. Really, they need to relate to each other. Without any relationship, we can see, A and B are highly associate each other for other reason, right? So number one, A and B must be related to each other. Number B, if you want to say A cause B, so proper time order must be established. If you want to say this gentleman is a son and this gentleman is father of this son, right? And you can't have the other way around. Are you with me? There are time stamp. This is father, this is son, because we are limited to that one directional time world, right? If you can go back to the future and those options are not permissible. So must A cause B. If you like to say A cause B, A should be prior to B. Okay? Proper time order. And third one is lack of alternative explanation condition. You should not have any other explanation relations between A and B. Relations between A and B must not attributed to third variable. We call it confounding variable. So experimental design is if whether you did an experimental design or not, people said highly internally valid. If you have a well-designed experimental research, you have a high degree of what? Internal validity, right? What do you mean by internal validity? Tenability of causal conclusion. So in short, if you connect them, to so why you are doing, what's the purpose of experimental variable related to causality? You have a much stronger tenability on causal conclusion related A cause B by doing what? Doing experimental research. experimental design, right? So causality and experimental design is very close to each other. The other way around, if you don't have any experimental design and you have a very poor causality, you have a very pure tenability of A cause B conclusion. Again, correlation exists between coffee drinking and heart attack. Coffee drinkers have a highly associated with, heart attack, right? So can you draw a conclusion coffee drinking cause heart attack or not? See, there is, that kind of thing, right? Even though they highly associate each other through data, right? So why? Because the third reason, for example, smoking, make you more drinking coffee than other non-coffee drinker, non-smoker, and then also smoking cause lung cancer, right? So without control for the third variable, which is smoking variable, right? It's important to control for that confounding variable to make those association between coffee drinking and heart attack, association. So you can think about confounding. You choose two variable, and you don't have any confounding variable like cigarette smoking. Even though you saw very high association between two variable, is there any confounding variable, right? To do it, what is the goal of our research design? Try to control for, eliminate the influence from those confounding variable, right? So how to do it? Doing well-designed experimental research. Okay, that's actually conclusion. Threats to experimental validity. Again, there's a external threats and also construct validity. Those things are we will especially threats. External threats are whether those experiments are interacting with other variable, right? And construct validity, we will talk about that is like more like operational, adequate operational definition is needed to have strong construct validity, but we will talk about that one later. Right? Threat External threats are very simple in here. Any interaction between selections and experiment and testing and experiment, etc., hard to generalize it, right? The more important thing in this class is we will talk about threats to internal validity, right? Internal validity. All right. There are several internal validities: history, maturation, regression toward means, mortality, testing effect, instrumentations, selection bias, or selection maturation, interaction, etc., right? Right. So let's talk about history effect. What do you mean by history effect? You know what? There's some very unique event occurring during experiment. So even though you find out some result, so we don't know that result is from your treatment independent variable or that particular event, historical event effect. Sometimes they call it as event effect. So when something happening during that experiment, sometimes war, there's some huge fight going on outside, and all subjects are biased to that particular event. It's hard to generalizable, right? Special event may influence onto your study result. We call it history effect. And also we cannot replicate that history, right? History is important. We cannot replicate. We don't know what will happen again, right? So we all of a sudden these becomes what? Threats to internal validity. In short, we don't know that conclusion, how much of that conclusion is due to that particular event. So we hope no drama going on when you are doing experimental research. Okay? Again, example, in short experimental design to investigate effect of computer-based instruction, and subject missed some instruction because of power failure at the school, right? And when we were high school, not high school, college school students, there are always fire alarms during final exam seasons, prevent of our, assessment, right? So whether that power failure may impact onto your research conclusion or not, right? Special event, right? Maturation. When you are, and then you had a reasonably long, right, experimental duration, and then you measure students are growing, right? So whether your experiments are making students are stronger. But what happened when you choose, elementary school? Elementary school students are getting stronger over time anyway. Are you with me? So can you really separate that natural, by natural growing compared to your experimental effect? So there are several ways of separating out. Well, I think my treatment actually really changing above and beyond natural growth, right? So there are several methods to. We have to understand those potential risks exist. Maturation. Human subjects are changed over time anyway. Every human beings are dying anyway. As soon as they were born, we are dying, right? We can't just live forever. We can't just get stronger forever, right? Example: fatigue decreasing every after 45 minutes because of fatigue, right? Over time they're changing, performance changing, either gets bigger or gets smaller, gets stronger, or other thing, right? So time does matter. To to eliminate those time effect, what you like to do: design appropriate time span. Don't make too long, too short. But if you make it too short, what happens? You cannot capture. Sometimes cognitive development take time. Even though you do the beautiful experimental experiments, treatment, but it take time to their brain growing, right? Responding your experiment, right? Regression toward means. Regression toward mean is if you choose regression analysis, one of the most popular statistical method to doing your analysis. I would say more than 99% of, not 99, anyway, most significant portion of your statistical analysis is based on regression. But all those regression models are linear models are about the average. Even you do the treatment group average compared to experimental group average, right? Average is very good. Why? Because they're aggregated value, but it's very dangerous. So in future, I will talk about Simpson's paradox. Sometimes because you compute average, you draw conclusion based on average, your experimental result will completely different. Average is very dangerous. Number two, in average, because let's say average, you compute average comparison, right? We compute the average, but average is what seriously biased toward outlier. Only one or two data point may dramatically change your average value, right? So regression toward the mean, which is what we call it as a mean variance model. A lot of statistical analysis based on average and variance, right? And average and variance need to be, it is very sensitive to the heterogeneity of subpopulation or those outliers. So for now, we don't have, I think it is too much for the going to Simpson's paradox heterogeneity of subpopulation issue, right? But well, let's talk about this outlier issue first. One more time. Because of outlier may significantly influence on the average value. And then most of statistical analysis based on mean and variance, which is regression is what? Modeling averages, right? So we have to be careful to not violating those one of assumptions of regression analysis, which is no outlier issue. If you have outlier, you draw wrong conclusions, right? Okay, the same thing I already explained to having a average issues, right? Mortality, differential loss of participants across groups. Sometimes number one, mortality, if you have like a first group, second group, and third group, right? Everybody's dying. Every human beings are dying. You cannot guarantee all subjects are remains into that group. Are you with me? Right? But if you have a huge loss in your experimental group, and what happened? And a huge loss in lower level groups, and all of a sudden overall average will boost it up. If you have a huge loss in high level group, what happened compared to other groups? All of a sudden your average outcome will be decreased than it's supposed to be, right? So if proportionally loss percentages occurring to entire group, that's okay. Oh, 10% of mortality, 10%, 10%, that's okay. But certain group had a huge mortality, and then that one really torturing, really, really, changing the conclusion the other way around. That's very that's reason why percentage of mortality and pattern of mortality is very important, especially if you're interested in involving longitudinal or change over time research, right? Example, health experimental design designed to determine the effect of various of exercises. Those subjects who find the exercise most difficult stop participating. So in certain group, high level, right? And then nowadays I'm doing that 30-day six pack, challenges, right? And if you and there's three level, like fat lose and medium and whatever that six pack rock. There's a three level. If you randomly assign subject into falling into one level, there is a chance of mortality. No, I don't want to do it. Stop doing that experiment. Occurring in what group? Intense group. Too intense or too boring. Whatever that extreme level tends to what? They just stop doing it because it's too tough to do it or too boring to do it compared to other groups, right? So that one actually what influence on the overall average dramatically, right? Testing. All right. So testing is another very big challenging thing. Did the and post pre-test affect the scores on the post-test? And most of study, experimental study involving pre and post, multiple measurement, right? So score on X, because a subject get to know what scores on the pre-test sometimes, right? If they get to know whether that score or that pre-test influence onto post-test or not. Sometimes we call it as a pre and post effect. Sometimes we call it as a memory effect because subjects start to memorizing those instruments pre-test. And then also, oh, to get rid of those tests, I want to have what different test. Pre-test, post-test is different, so they cannot memorize. But what happened? Are you really comparing pre and post? Because apple and orange. Final exam is different from whatever that classification the pre-exam, right? So how you can compare two scores came out of from the two different tests, right? That's one of the most, one of the most tough challenges in testing assessment field. How we can create, how we can create equivalent test. We call it a parallel test. How we can create parallel test? If we can design parallel test, that's parallel means what? They're not same, but they're equivalent. They had a similar characteristic, but they're not same. So that's the reason why we don't have the memory effect, carry over effect anymore. But that's very, very tough. We spend thousands of time to create those parallel forms, or two assessments are equivalent through equating process, another expensive time consuming process. All right. Example, in an experiment in which performance on logical reasoning test is dependent variable, pre-test cues the subject about the post-test. Because if you want to have a logical reasoning performance, right, you really want to measure to that cognitive ability before and after treatment, right? But subjects are what? Oh, I think I can memorize what's going on in here. So basically, they're not increasing. Their logical ability start to change not because of experiment, but because of they familiarize that particular exam test. So we call it as a testing. Again, what are the other names of testing? Testing, carryover effect. Sometimes we call it memory effects, and or sometimes we call it test retest effect. All those names are same in this class. Instrumentation. Did any change occur during the study in the way of dependent variable was measured? Right. So definition of measure or operational definition of measurement may change those, because of the you decide that the dependent variable is that way, they may cause some problem, right? Because you designed your dependent variable is a threat to one group or not to two group design. Why? Because two experiments for the, let's talk about this example. Two examiners for an instructional experiment administered the post-test with different instruction and procedure. What's the problem in this case? Why? Because different instruction, different procedure, your dependent variable is measured by differently. It's like a consistency. It's more like a it's very close to what? Reliability, consistency of what? Data collection issue. So how you can compare apple and oranges? Your dependent variable operationalized differently. Administered the post test different with different instruction and procedures, right? So that is instrumentation part. So instrument operational definition, how you operationalize your variable may cause a problem. Again, this is very close to internal reliability, consistency. Very close to internal reliability issue, right? In this example. So validity and reliability is not a completely different thing. In this case, it's nearly same situation. Instrumentation. Selection refer to the selecting variable for various, for the various groups in the study. Are the groups equivalent at the beginning of the study? We call it selection bias. Selection bias is huge. Let's talk about group A, B, C. The one of the easiest example to doing that research is what? you let subject choose one of the group. Are you with me? Subject choose one of the group. Hey, choose which option you like to do. That causes a selection bias because there is a reason group of students why they choose this particular experimental groups. We fail to control the reason why those subjects are choose that particular control. Or how about that? You choose it. You know what? I like to assign this my 6112 students, this group, into my first experimental level. And then I like to assign the 8174 group students into second groups. What happened? I assigned the students, the 6114 students as treatment A, another classroom students, I did it. You don't have choice. What happened? That also selection bias going on because I made different groups. We fail to control the potential different. They're not equivalent. 6114 students are not exactly same as 8174 students, right? We get exposed to that potential risk. In other words, how we can describe that one? Those groups are may not be equivalent at the beginning of the study. It's a very, very important definition. May not be equivalent. So, in short, listen, how we can make two groups are equivalent? We already talked about that issue in random assignment. Random assignment. We randomly assign subject into groups. Not me, not you. We create flipping coin, throwing a dice. Let's randomly assign subject, group of subject into different groups. And then that activity reduce down selection bias, right? Number one. Number two, if you randomly assign, what happened? Those groups becomes equivalent at the beginning of the study. One more time. It's very important. Random assignment make your groups are equivalent at the beginning of the study. If all those things, all groups are reasonably, perfectly equivalent, and then your research experimental design is well performed. What happened? You able to control spurious, extraneous variable, eliminate effect from from spurious or extraneous variable effects. By what? By what? Random assignment. If you do it now, okay, I started with very equivalent group. They're very start from very equivalent. I control very well, and I see the differences. And then you can say what? You can say what? If you do it. So in the end, what is good? You have a very strong internal validity, right? What do you mean by internal validity? Degree of tenability of causal conclusion. So if you do experimental research, random assignment with reasonable sample size, with increasing what? Huge amount of what? Internal validity, and then your conclusion had a what? Very strong tenability of related to what? A cause B. If you have a poor job, no random assignment, like lots of testing issue, maturation issue, selection bias, right? And then you cannot control the other extraneous variable appropriately, and then still you got some conclusion, right? And then we call it as what? Poor, poor tenability of internal validity. How you can say? I know you can draw still strong differences between independent variable is very significant independent variable for the dependent variable statistically, but causality, no. One more time. You may find out very strong statistical significant relationship between independent variable, dependent variable. But if your research design sucks, what happened? Tenability of A cause B is very, very, very what? Weak. So having a strong research design is very important. At this moment, we will talk about what? Strong internal validity of your research through research design. Right? Again, this is an example. Experimental group instructional experiment consists of high ability class while comparison was average ability class, blah blah blah. Right? Two groups are different. One groups happen to be for some reason average ability comparison group. You do the experimental group is high ability. We don't know that difference between high ability class and experimental group average and control group averages because of their precondition or because of your experiment. So key point is what we need to make two groups are as equivalent as a possible, which is what reduce down selection bias and using what typically what is random assignment make those groups are as equivalent as possible. Otherwise you have to make sure two groups are equivalent. Are you with me? All right, types of experimental design, and we will talk about that issue a little bit later. All right, types of experimental design. Experimental design, the first experimental design is post-test only, and then also control group design as well. So this case is what? You had a control group, but you only have a post-test. That's the reason why we call it post-test only. Post-test only is what? See, randomly assigned groups, randomly assigned subject into two groups, and you had a what? Or so, control groups, right? And one treatment groups, right? And observation after treatment. Are you with me? That's the reason why post-test only. Post-test design is what? If you randomly assign students to different types to stress reduction method, in random assignment is good thing is what? You only have a one observation. After intervention done, you measure it. But what is the cons? What's the concerns about this one? You failed to measure preconditions, right? So in this case, even though you did a random sample, random assignment make two groups are equivalent. Are you with me? But unless you don't have a lot of sample size, you can full take advantage of that random assignment. Let's say only two people randomly assigned group one and two people randomly assigned group two. How much they're equivalent? If you randomly assign large number and group two, two groups becomes equivalent. And the random assignment is not easy because you need to have a what? Large number of subjects to willing to participate, willing to being randomly assigned. That's a cons. That's the reason why we quickly finding out. Look at this. After you assign, and then they measure first before intervention. They measure, and after intervention in these groups, and they don't have any intervention. We call it as a control group, and then they measure again. In this case, you can control for, we control for a baseline. We understand where is a baseline and then start to do one repeated measure or longitudinal study. The most simple version of longitudinal study, not the most, you can have a case study, but the experimental setting, you can measure again and again. And then you can see the deviation between O2, O1 versus O4, O3, right? So like her case, the students are growing, but this control group growing is what? A lot less steeper than experimental group growing. Experimental group O2 is what? O2, O1 difference is a lot bigger than control group O3, O4. Why? Students are growing anyway. They'll get stronger anyway over time, right? But this growth change is a lot bigger than this O3 and O4. And then where that is a benefit of having pre-test, post-test. But idea is what? There's a two challenges. Number one, obviously, it's expensive. You need to analyze and collect the data. Assessment is very expensive. Number two, for her case, less concerns. Why? They're measured by what? Strength, right? Memorizing how today measure strength is not a big deal to next time, right? But how about her case? Algebra. See, a certain period later, they need to take algebra again, right? They familiarize algebra exam itself for the post test, right? So creating equiparallel test is very, very expensive. It's not easy to doing, especially doing what? That kind of cognitive achievement test. Physical achievement test, relatively okay. But cognitive ability assessment is different story. Especially high stake test. No, they really want cheating is very, very important. Threats to, you know, um, the validity, right? Solomon's four group design. They are four group. One, two, three, four. Okay, this is typo. Four groups. And once they setting up the four groups, and then they measure those two groups first only, not every two groups only. Pretest for these groups only, and then doing intervention. So these two groups are not taking observation, and then this is post-test only. And then these groups are not even first observation, control group, and post-test. In this case, let me tell you why. Because you randomly assign, you save some money for these two groups to relate it to pre-observation. But still you can see, right, those intervention group average versus control group average comparison is possible. So basically, this is a special case of what you're not doing. You reduce down. In short, you reduce down some money for half of group pre-test pre-test issue. So if you do it, so if these guys are really boosted up, because these guys had a what? This group one and group two, they do have a pre-test. You can analyze whether there is testing effect or not in this group. So group three and group four, they don't have test effect. Why? They haven't take pre-test. You reduce down pre-test money, and then also you can evaluate whether pre-testing effect is going on or not, because you're separating out two. Basically, this is cleverly separating two groups into four groups, and then exercising those pre-test, post-test, and experimental group, control group combination into four scenario. All right. Again, this is what when we need to think about this one when we are concerning the test effect and when we are concerning the money involving those pre-assessment, difficulty involving pre-assessment, right? Factorial design is another one. Right now, you only had a one intervention case, but you can think about multiple interventions, right? Solomon 4 group falling into this like a factorial design. Factorial design, again, in short, you have a multiple independent variable. Gender and treatment. Ethnicity and treatment. So you have two different, like a school type, public school and private school, and treatment. So if you like to integrating those multiple independent variable, in general we call it a factorial design, multiple factor there, right? And then also the most important thing is you can investigate interaction between two independent variables. Good question. Good question. Sometimes gender, if you adding gender is not manipulatable, right? Gender is non-experimental independent variable and your intervention is experimental variable. You can combining both of them. So ethnicity is not, we cannot manipulate ethnicity. You become Asian. At least one that is experimental research. Most of case for simplicity, let's have only one experimental variable in your study. Don't make like a multiple experimental research. I mean variable, right? Again, factorial design, but cons is what? Pros, you can analyze multiple independent variable and more control, but cons is what? Complexity. It's complex, complicated, and then your model becomes more complicated. So this is again two factor, two by two, two level, two level, full level, etc., etc. Repeated measure design is, I mean, whether you adding those pre-observation or not before, it's okay. Some repeated measure can have a pre-test, intervention, post-test, 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 post-test. Why you are doing this one? Why you need to do additional post-test? Because you really want to see how long, okay, longevity of the dose effect. You can analyze. You do the experiment. How long dose effect is sustained over time, right? Sometimes, oh, they improved. Their strength improved. But all of a sudden, and it takes 3 months to those things getting back to normal after you stop doing intervention. Sometimes, wow, once you teach kids how to doing catching a fish at that moment, they'll keep growing over time, faster, faster. Because early childhood intervention is very important to that kind of skills. You really teach how kids catching a fish. The method is so, right? Or it's a one-time shot or more sustainable over period of time, right? So you can do the intervention effect over growth and sometimes lifetime, how they are different over time, right? So repeated, so pretest, remember, pretest post-test is a special case of repeated measure anyway. I will argue, even textbook not saying, pretest, intervention, post is also repeated measure study. Sometimes you do the intervention again and again and again, see what's going on. Some group of students are what? Measure, intervention, measure, intervention, measure all the time. And the other group is what? Measure, intervention all the time and not doing intervention anymore, but keep measuring. Are you with me? So you can thinking about that kind of particular scenario. Pros and cons. The most important thing is what? Mortality. Because subjects are keep going and you cannot track them and you need money and they're not come back because it's take over, right, over time. And in research lab, what is the most important thing in if you do a multiple measure, repeated measure? What is the biggest challenge in research lab? Memory testing. They keep memorizing it. Oh yeah, this test is so familiar, right? They're just tailored to, they start adjusting that instrument over time. So creating that parallel test, wipe out memory is very, very expensive, right? So that is a cons. And then that's the reason why automatic item generations and parallel form generators and that kind of new technologies needed to 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 get rid of those threats testing effects. All right, interpretation. I think I already explained that one and when we're doing it. Whether these groups, right, average is same as this group, which average is these two group averages are same or not, or all those group averages are same or not. That kind of things are research question. Let's go with this. What is this? Your research questions. This one is different from each other. This one is different from each other, and one two is what? These two things are same or not could be one question. In yoga group, pre-test, post-test are same or not. That could be one research question. You can interpret, focus on one and two. And the other one is what? 2 and 4s are same. In these two groups are same, but not same and not for O2 and O, 2 and 4 is different from 6. So that kind of research question you can answer it within experiment, or sometimes you can do what? Whether 2, 4, 6 are different from 8. 8 is what? Control group. No exercise, not don't do anything, right? So whether 8 is different from 2, 4, 6. That could be one of your research question. The many research question came out of from here. Average of the 2, 4, 6 is the same as average of 8. So you can you can formulate that kind of some combination of your different averages as well. Yeah, exercise is same as homework. Let's talk about homework briefly. I think we don't have much time, but it's better than not talking, right?